Li Qing spent a decade taking blood samples from people before and after they walked into forests. Not hiking, walking. Slowly, on flat ground, for 2 to 3 hours, through air that smelled like pine. He drew blood before they entered. He drew blood after. And in study after study, across years of replication, an identical result. The blood that came out was measurably different from the blood that went in. Natural killer cell activity. The immune system's primary surveillance against cancer cells and virus-infected cells was elevated, not by a small margin, by roughly 50%. And the elevation persisted. Not for hours, for 30 days. For 30 days. One weekend under the trees produced a month of enhanced immune surveillance. Mechanism was not exercise, not relaxation, not the psychological pleasure of being outdoors. It was in the air. The trees were dosing the bloodstream through the lungs with volatile compounds that directly activated the cells responsible for finding and destroying abnormal tissue. There is a timeline to what the forest does to your blood. A sequence of changes that begins with the first breath and reaches a measurable threshold at roughly 30 minutes. And there is a molecule in the air beneath the canopy that enters your bloodstream within minutes and reaches your immune cells before you have walked 100 meters. Both come later. So does the finding that the forest floor itself is an electrical surface, and that walking on it barefoot produces cardiovascular changes measurable in the viscosity of your blood. Start with the air, because the first thing the forest does to your body happens through your nose. Within seconds of stepping beneath a canopy, your olfactory epithelium encounters a class of molecules the trees have been releasing continuously into the air column beneath their leaves. Phytoncides. Volatile organic compounds synthesized by the tree's own metabolism as part of its antimicrobial defense system. Alpha-pinene and beta-pinene from conifers. D-limonene from broadleaf species. Camphene from firs and cedars. Each one a terpene, a hydrocarbon built from isoprene units, light enough to evaporate at ambient temperature and disperse through the air as an invisible chemical cloud. Boris Tokhin at Moscow State University named these compounds in 1928 after demonstrating that the air within pine forests contained active antimicrobial agents. His experiments were direct and dramatic. Protozoa placed on fresh pine tissue died within seconds of contact with the volatile emissions. The compounds were potent enough to sterilize the air in a sealed chamber at the concentrations a living tree generates. Scale of production is enormous. A single hectare of pine forest releases approximately 5 kilograms of these molecules into the atmosphere on a warm day. More on hot days, when the stomata are fully open and the metabolic rate of the tree is highest. On a summer afternoon, the terpene output of a mature conifer forest is continuous and substantial. The trees are running a chemical manufacturing operation that has been operating without interruption for the entire life of the forest. The pharmaceutical output of a single hectare of pine forest, measured by mass of bioactive compound released per day, exceeds the output of many small manufacturing facilities. The difference is that no one is collecting the output. It disperses into the air column beneath the canopy and waits for something with lungs to breathe it in. Air beneath a forest canopy is not just air. It is air carrying a continuous pharmaceutical load generated by the trees that shade it. On a warm afternoon in a conifer forest, the terpene concentration in the air column beneath the canopy can reach 50 to 100 micrograms per cubic meter, invisible, largely undetectable by smell at those concentrations, but pharmacologically active at the cellular level. The concentration is highest in still air beneath dense canopy, where the molecules accumulate without being dispersed by wind, and lowest at the forest edge, where air circulation carries the compounds away. The deeper into the forest, the higher the dose. Your first breath under the canopy delivers a detectable dose to the olfactory epithelium and, through the lungs, to the bloodstream. Terpenes are lipophilic, fat-soluble, which means they cross the alveolar membrane readily, dissolve into the blood plasma, and distribute through the body within minutes. By the time you have taken 20 breaths beneath the trees, the compounds are circulating. Dose accumulates with every breath. A person breathing normally at rest inhales roughly 6 liters of air per minute. Walking slowly, the pace Lee used in his studies, increases ventilation to roughly 12 to 15 liters per minute. Each liter of forest air contains the phytoncide load the canopy above has been generating and accumulating in the still air beneath the leaves. An hour of walking through a conifer forest at moderate pace delivers roughly 800 liters of phytoncide-laden air through the lungs, each liter depositing its terpene cargo into the bloodstream through the alveolar membrane. The cumulative dose is substantial, and it continues to build for the entire duration of the walk. You cannot smell most of them at the concentrations a temperate forest generates. What you smell as the forest, that particular clean, resinous quality that distinguishes forest air from urban air, the scent that arrives the moment you step off the road and under the trees, is the fraction of the total terpene load that exceeds your olfactory threshold. Beneath that fraction, at concentrations your nose cannot consciously detect, the rest of the molecular cargo is entering your lungs with every breath and reaching your blood without your awareness. The forest smells like something. The pharmacology runs on what it smells like and on everything beneath that threshold. Now, what those molecules do when they reach the immune system, because this is where the forest stops being an environment and becomes an intervention. Natural killer cells are lymphocytes, white blood cells that circulate continuously through the bloodstream and patrol the tissues for cells displaying abnormal surface proteins. Virus-infected cells display viral peptides on their surface that healthy cells do not. Early-stage cancer cells display aberrant proteins from their mutated genome, molecular flags that mark them as abnormal. NK cells detect these markers through a system of activating and inhibitory receptors on their surface, a molecular identification protocol that allows them to distinguish normal cells from abnormal ones without requiring prior exposure to the specific pathogen or mutation. Healthy cells present MHC class I molecules on their surface, a molecular identity tag that signals self and suppresses NK cell attack through the inhibitory receptors. Virus-infected cells and cancer cells often downregulate MHC class I to evade the adaptive immune system, and in doing so, they remove the inhibitory signal that was protecting them from the NK cells. The absence of the inhibitory signal is itself the activation signal. Missing self triggers the kill. What follows is rapid and mechanical. The NK cell makes contact with the target cell and forms an immunological synapse, a tight junction between the two cell membranes. Through this synapse, the NK cell releases the contents of its cytotoxic granules, perforin molecules that insert into the target cell membrane and assemble into transmembrane pores, and granzyme enzymes, serine proteases, that enter through those pores and activate the target cell's own self-destruction program. Apoptosis. Programmed cell death initiated from outside the cell, executed by the cell's own molecular machinery. The target cell dismantles itself from the inside. The NK cell detaches and moves on to the next target. The entire kill takes minutes. NK cells are the immune system's first responders, capable of killing a target cell within minutes of detection, without the weeks of antibody development that the adaptive immune system requires. They are the surveillance system. They are running continuously, and the phytoncides upregulate their capacity. When alpha-pimeni and beta-pimeni reach NK cells through the bloodstream, they stimulate the expression of three proteins the kill sequence depends on: perforin, granzyme A, and granzyme B. More perforin means more effective membrane penetration. More granzymes mean faster target destruction. The phytoncides are upregulating the killing machinery. Li Qing at Nippon Medical School measured this across multiple studies spanning a decade. Subjects who spent 2 to 3 hours walking through forests with high terpene concentrations showed roughly 50% increases in NK cell activity, measured in blood samples drawn before and after exposure. The activity increase reflected both a rise in the number of circulating NK cells and an increase in the per-cell killing capacity. Each NK cell was producing more perforin and more granzymes than before the exposure. Persistence was the finding that carries the weight. NK cell activity remained elevated for 7 days after a single day of forest exposure. After a 2-day weekend exposure, the elevation persisted for 30 days. One weekend under the trees, producing a month of enhanced cancer surveillance from a single exposure to airborne terpenes. The decay curve matters as much as the peak. After the initial elevation, NK cell activity does not drop abruptly back to baseline. It declines gradually over the 30-day window, with the steepest decline occurring in the final week. A person who visits a forest on the first weekend of the month is still carrying measurably elevated NK cell activity at the end of the 3rd week. By the 4th week, the elevation has largely decayed. The biology is suggesting its own dosing schedule. Implication is dosing. A person who visits a forest once a month is maintaining continuously elevated NK cell activity, each visit refreshing the 30-day window before the previous one has fully decayed. 12 weekends per year. Continuous immune enhancement. The forest is not a single intervention. It is a maintenance schedule, and the dosing interval the biology suggests is approximately monthly. Well, and here is where the mechanism was isolated from the experience, because the obvious question is whether the immune effect was produced by the forest or by the experience of being in a forest, by the terpenes specifically, or by the relaxation, the exercise, the visual beauty, the break from routine. Lee tested this directly. Subjects were placed in hotel rooms. No forest, no trees, no exercise, no visual beauty, no birdsong, no canopy light. Synthetic alpha-pinene and beta-pinene were diffused into the room air at forest, ambient concentrations. Blood samples drawn before and after showed NK cell increases comparable to the forest exposure. The chemistry alone was sufficient. The forest's immune effect could be reproduced with 2 molecules in an air diffuser in a hotel room in Tokyo. That was the finding that settled it for me, because it strips away every explanation that attributes the forest's immune effect to the experience of nature rather than to the specific molecular cargo the trees are releasing into the air. Relaxation did not produce it. Exercise did not produce it. The pleasure of being outdoors did not produce it. 2 terpene molecules in a sealed room produced it. The experience of a forest is real and valuable. The cortisol reduction, the autonomic shift, the psychological restoration, all require the full sensory environment. But the immune modulation is running on the chemistry. The two can be separated in a hotel room. They cannot be separated under a canopy, which is why the forest produces the full effect and the hotel room produces only the immune component. Let that settle. The trees are manufacturing specific molecules that, when inhaled by a human being, directly upregulate the immune system's primary cancer surveillance mechanism. The effect is dose-dependent, duration-dependent, and persistent for weeks after exposure. The mechanism has been isolated from every confounding variable the research could identify. The air beneath the forest canopy is not metaphorically healing. It is pharmacologically active. Second system comes next, and this one operates on a faster timeline than the immune response, and it connects directly to why the immune response is so strong. Cortisol. The glucocorticoid that the HPA axis releases in response to stress begins to fall within minutes of entering a forest environment. Bum Jin Park at Chiba University conducted the most cited physiological study of forest bathing in 2010, measuring salivary cortisol, heart rate, blood pressure, and autonomic nervous system markers in subjects walking in either a forest or an urban environment at identical exercise intensities. In the forest, salivary cortisol fell significantly within the first 20 minutes. Heart rate decreased. Blood pressure dropped. Heart rate variability increased. The signature of parasympathetic dominance, the autonomic state of recovery. Sympathetic nervous system activity, the fight-or-flight activation that chronic urban living maintains, decreased measurably. Every marker moved in the direction of reduced physiological stress. In the urban environment, with identical walking speed and duration, the markers did not move in equivalent directions. Some worsened. The effect was not exercise, it was the environment. The multisensory input of the forest producing a coordinated autonomic shift that urban walking could not replicate. Cortisol timeline is specific and it matters. Steepest decline occurs in the first 15 to 20 minutes. By 30 minutes, the cortisol level has reached a plateau, a new, lower baseline that the forest environment maintains for the duration of the exposure. The speed of this decline exceeds cortisol reduction from most pharmacological interventions designed to produce relaxation, because the forest is not operating through a single pathway. The phytoncides in the air, the acoustic environment, the visual canopy, the quality of the light, multiple sensory channels are driving the autonomic shift simultaneously, producing a convergence that no single intervention replicates. Think about what this means for the person who arrives at the forest carrying the cortisol load of a stressful week. Elevated baseline, suppressed immune function, sympathetic dominance, disrupted sleep architecture. Within 30 minutes of entering the canopy, the cortisol curve is bending downward. The immune suppression that elevated cortisol maintains is beginning to lift. The parasympathetic system is gaining dominance for the first time in days. You know this as the specific feeling that arrives after 20 minutes on a forest path. The shoulders dropping, the breathing deepening, the jaw unclenching, the thoughts slowing from their urban pace. The quality of that feeling is different from relaxation achieved indoors, different from a hot bath, different from a glass of wine, different from sitting in a quiet room. The difference is that the forest is driving the autonomic shift through multiple sensory channels simultaneously, producing a depth of parasympathetic activation that no single channel intervention matches. They attribute it to being away from work, to fresh air, to the beauty of the trees. The beauty is real. The mechanism is cortisol falling through multiple sensory channels simultaneously. And here is where the two mechanisms converge. Because cortisol reduction and NK cell activation are not independent effects. They are mechanistically linked. Cortisol is one of the primary immunosuppressive hormones. At chronically elevated levels, the levels that reeks of stress, poor sleep, and urban sympathetic dominance produce. Cortisol actively suppresses NK cell function. The killing machinery is present. The cells are circulating. But the cortisol is holding the breakdown on their activity, reducing the production of perforin and granzymes, limiting the surveillance capacity the immune system can deploy. Consider what this means over time. A person running elevated cortisol for 3 weeks, which is not unusual for someone managing a stressful period at work, caring for a sick family member, or dealing with financial pressure, has been suppressing their NK cell function for 3 weeks. 21 days of reduced immune surveillance. 21 days during which aberrant cells that should have been detected and destroyed may have been missed because the cells responsible for detecting them were running at reduced capacity. The cortisol did not create the aberrant cells. It prevented the system that finds them from operating at full efficiency. Over years, the cumulative probability that suppressed surveillance misses a cell that full surveillance would have caught is not zero. It accumulates. When cortisol falls, as it does within 30 minutes of entering a forest, the brake lifts. NK cells that were running at suppressed capacity begin operating at their normal functional level. Simultaneously, the phytoncides circulating from the first breaths under the canopy are actively upregulating the same machinery that the cortisol had been suppressing. Two mechanisms converging on the same immune outcome through opposite actions. The cortisol reduction removes the suppression. The phytoncides add the stimulation. The result is not additive. It is multiplicative because each mechanism amplifies the effect of the other. Anyone who has been chronically stressed, running elevated cortisol for weeks, sleeping poorly, carrying the sympathetic load of a life spent largely indoors in an urban environment, is the person whose NK cells are most suppressed and who therefore benefits most from the dual mechanism the forest provides. The immune system most in need of reactivation is the one the forest reactivates most powerfully. And here is what all of it adds up to. 30 minutes. That is approximately how long it takes for the major systems to shift. The cortisol decline. Park measured reaches its plateau near 30 minutes. Heart rate variability has shifted toward parasympathetic dominance. The phytoncide dose has been accumulating with each breath and reaching NK cells through the bloodstream. Though the full NK cell activation Li measured requires sustained exposure over hours and builds over days. At 30 minutes, the transition is substantially underway. Cortisol is down. Parasympathetic tone is elevated. Phytoncide dose is circulating and reaching NK cells. The brake on NK cell function has begun to lift. None of these shifts required the person's awareness. None required their cooperation. None required them to meditate or breathe in a particular pattern or hold any intention about health or wellness or immune function. The forest delivered the phytoncides through the air. The person was already breathing. The cortisol responded to the sensory environment the person was already standing in. The person's only contribution was presence. Being physically under the canopy for 30 minutes, the body did the rest because every system involved was responding to stimuli. It evolved to recognize and had not received in the weeks or months since the last forest exposure. Person who sat on a bench under a tree for 30 minutes and read a book received the same phytoncide dose as the person who walked purposefully through the forest with the explicit intention of improving their health. The molecules do not require intention. They require inhalation. The cortisol does not require mindfulness. It requires the multi-sensory environment. The biology is indifferent to the person's reason for being there. Body has not arrived at a new state. It has returned to an old one. The physiological baseline it was designed to occupy, the state that the species spent most of its evolutionary history inside. Calm that arrives at the 30-minute mark is not the forest doing something extraordinary to the body. It is the forest allowing the body to stop doing something extraordinary, to stop maintaining the elevated vigilance, the chronic cortisol load, the sympathetic dominance that the urban environment imposes and that the body sustains at continuous metabolic cost. The elevated state is the abnormal one. The body has been running the urban stress program, maintaining cortisol, suppressing immune function, holding the sympathetic nervous system in dominance, because the sensory environment was telling it to stay alert. The forest provides the sensory signals that tell the body the alert is over. Metabolic cost of chronic sympathetic dominance is not abstract. It is measured in cortisol that suppresses immune function, in cardiovascular strain from sustained elevated heart rate and blood pressure, in disrupted sleep architecture from insufficient parasympathetic recovery, in the cumulative wear of running a stress response that was designed for acute threats as a chronic background program. The forest reverses the program. The reversal begins in minutes. The immune consequences persist for weeks. One more layer, and this one sits on different ground from the research already described. Surface of the Earth carries a mild negative electrical charge maintained by approximately 5,000 lightning strikes per minute worldwide, depositing electrons into the ground through the global atmospheric electrical circuit. The human body, insulated from this charge reservoir by rubber-soled shoes and synthetic indoor flooring, accumulates a mild positive charge through the continuous oxidative reactions of normal metabolism. Walking on natural forest ground, soft soil, leaf litter, damp organic material, all of which are electrically conductive, allows electrons to flow from the Earth's surface into the body along this voltage differential. The transfer is immediate on contact and continues for the duration of grounding. Bare feet maximize the transfer. Thin-soled leather shoes permit partial conductivity. Rubber soles block it entirely. Gaetan Chevalier at the University of California measured the cardiovascular consequences. Grounded subjects showed increased zeta potential on red blood cells, the electrical surface charge that causes red blood cells to repel each other and remain in suspension rather than aggregating. Higher zeta potential means the red blood cells carry a stronger negative charge, creating greater electrostatic repulsion between them. They remain separated. They flow as individual cells, rather than clumping into aggregates that increase viscosity and resist flow through narrow vessels. That finding caught me differently from the others, because it means walking barefoot on soil is changing the electrical properties of your blood, not metaphorically, measurably. The grounding research is newer and less replicated than the phytoncide or cortisol literature. The physics is straightforward, and the measurements are specific, but the field has not yet accumulated the decade of independent replication that Lee's work represents. The mechanism is plausible. The early data is consistent. The certainty is lower. Lower blood viscosity means reduced resistance to flow through the capillary beds, the microscopic vessels where oxygen and nutrient exchange actually occurs. Improved microcirculation means more efficient delivery of oxygen to the tissues and more efficient removal of metabolic waste. If the effect is confirmed by further research, it adds a cardiovascular layer to the forest's pharmacology, one that operates through the soles of the feet rather than through the lungs. You see, the forest floor may not be just a surface to walk on, it may be an electrode. The body walking on it may be the circuit. The electron transfer may be producing cardiovascular changes that add to the immune and endocrine effects already running through the air. The research is young. The physics is old as the voltage differential between the Earth's surface and the metabolically active body that walks on it. Consider where most people actually spend their time. A person over 65 in a developed country spends approximately 93% of their time indoors. That number includes the home, the car, the office, the supermarket, the doctor's waiting room. Every enclosed space with filtered air, artificial light, flat synthetic flooring, and an acoustic environment dominated by mechanical noise and human speech. 7% of the time outdoors. And most of that 7% is in urban outdoor environments where the phytoncide concentration is negligible and the ground surface is asphalt or concrete. Arithmetic is stark. A body that evolved to spend its entire existence in a forest environment now spends roughly 0% of its time in one, not 7%, because urban outdoors does not provide the phytoncide load or the soft conductive ground that a forest provides. The actual time spent in the environment the body was designed for is, for most people over 65, effectively zero. Think about what that means in terms of the immune data. 30 days of NK cell elevation from one weekend of forest exposure, 52 weeks in a year. If the person visits a forest 0 times per year, which the 93% indoor statistic suggests is close to the reality for many in this demographic, their NK cells have been running at unsupported baseline for years, not suppressed by illness, not reduced by medication, simply unenhanced. Operating without the phytoncide stimulus that the research shows can elevate their function by 50%. The immune surveillance deficit is not dramatic in any single week. Across a decade, the cumulative difference between supported and unsupported NK cell function is the difference between a surveillance system that routinely catches aberrant cells and one that sometimes misses them. Physiological state that forest exposure produces. The NK cell activity, the cortisol curve, the HRV profile, is not a bonus state. It is the baseline the human body was calibrated for across hundreds of thousands of years of evolution under canopies. Indoor environments do not generate equivalent NK cell activity, do not produce equivalent cortisol suppression, do not deliver equivalent parasympathetic dominance. Over decades, the cumulative effect of spending 93% of time in an environment that does not produce these states is a body operating chronically below its design specification, lower immune surveillance, higher cortisol baseline, sympathetic dominance. Gap between where the body operates and where it was designed to operate is not a deficit anyone chose. It is a consequence of living indoors in a species that evolved outdoors. And the gap widens with age, as the body's capacity to maintain immune surveillance and autonomic flexibility declines, at precisely the point when those systems are most needed. The 65-year-old body needs NK cell activity more than the 25-year-old body does because the cumulative probability of encountering an aberrant cell that requires immune destruction increases with every year. The forest exposure that maintains NK cell function is most valuable to the population, least likely to receive it. Trees do not know this. They produce phytoncides for their own antimicrobial defense, not for human benefit. Everything the forest does to the human body is a side effect of the forest being a forest. And the human body evolved inside that side effect for long enough that it became a requirement. Forest is not a luxury. It is not a holiday activity. It is not a wellness trend. It is maintenance of a biological system that evolved inside a forest, that still requires what the forest provides, and that responds to 30 minutes beneath the canopy with a cascade of measurable physiological changes that no indoor environment, no supplement, no medication, and no technology can replicate. Trip does not need to be long. The forest does not need to be remote. A park with mature trees and a canopy dense enough to accumulate phytoncides in the air column beneath the leaves will produce the cortisol shift and begin the immune cascade. A 30-minute walk on a wooded path, shoes off if the ground permits, adds what may be an electrical layer. Phytoncide dose begins accumulating with the first breath. The body begins shifting with the first minute. By 30 minutes, the cortisol decline has reached its plateau and the parasympathetic shift is established. The NK cell elevation builds over hours and persists for days or weeks, depending on the duration of exposure. The body does not require a wilderness expedition. It requires a canopy, air, and time. 12 visits per year, 1 weekend per month. Continuous NK cell elevation maintained by a schedule the biology itself suggests. The person who walks in a forest once a month for the next decade will have maintained roughly 50% higher NK cell activity across that entire decade compared to the person who did not. The maintenance schedule is not arduous. It is a walk in the woods once a month for the rest of your life. The body knows what the forest is. The science now measures what the body always knew,